Okay, question 9. What is the maximum compressive strain on a circular beam with an outside diameter of 200 millimeters and a wall thickness of 10 millimeters when loaded, that should be, when loaded with a 50 kilonewton as shown below. So, quite a tricky one this. Give it a go. Once you're ready, I will have a bash. The first thing is to do a kind of little sketch of your bending moment diagram, I think. So we've got 25 here, nicely in the middle, and then we can say to ourselves, well, therefore the shear force diagram looks like this, 25, then it drops and goes like that. So my bending moment diagram, where this is 2 meters, will be something that does this, and the peak of it will be 2 meters times by 25 kilonewtons. So the middle will be 50 kilonewton meters. So that's my M. That's what my M will be, 50 kilonewton meters. I guess I want to find my bending stress next. So bending stress will be M over I times Y. So you need to look up your second moment of area for a hollow tubey thing. Which I know is going to be, and the Y will be obviously half the diameter. So let's put that in D over 2 will be what the Y is. That'll be the outer distance away from the neutral axis. The I will be pi divided by 64, and this, the outer diameter, big D to the 4, take away little d to the 4, and that's the formula that I would need to use. So that's the stress. So we've got 50,000 we've got an outer diameter or diameter divided by 2, which is 100 millimeters. And we've got pi divided by 64 here. Outer diameter is 200, which I need to raise to the power of 4. The thickness is 10 millimeters, so the inner diameter will be 200, take away 10, take away 10, because we've got 2 thicknesses, so 180. Right, so all that pretty lot into my calculator, 50,000 times by 100 is my Reminds me of a Dawes test. Divided by pi, divided by 64, times by open bracket 200 to the power minus 3 raised to the power 4. Take away 180 times 10 to the power minus 3 raised to the power 4. Close my bracket. So that gives me a stress of 185.12 megapascals. Young's modulus is 70. So the maximum strain, I will assume simply to be stress over Young's modulus. So that gives me 158.12 times 10 to the 6 divided by 70 times 10 to the 9. So divide that by 70 to the 9 gives me none of those answers. Gives me, okay, press the Eng button. Going the wrong way. So I've made my Eng button to be 10 times 10 to the minus 6, and that then goes 2644 times 10 to the minus 6. This is a microstrain, and so that gives me answer D. Ooh.